Okay. Mm, okay, can you see my screen?
Yes, miss.
Okay, so last time I left you with this past year exam question. Anyone try? Anyone try this
Yes,
question?
miss.
Have
Yes,
you
miss.
get the answer?
Yeah.
Okay. Who else?
Already done.
Done. Okay, so let's check the answer. How about the rest? Have you tried? Huh? The
Yes.
rest? Okay. So here, okay, so by given a metric of 3 by 3, you should develop a cubic equation and show that the eigenvalues of metric A equal to 1 to 3. Okay, so and then another question, it asks you to find the corresponding eigenvector, and also the last one to compute the determinant. Okay, so let's write down the metric A. Okay, so for those who haven't tried this question, you may do together with me so that we can check the answer. Is it correct or not? Maybe in some of the calculation we tend to make mistake, right? So um, so let's do together. Okay, so this is your metric A. Okay, so metric A is 3 by 3, kind of a square metric. Okay, so now you are asked to find the eigenvalue. Okay, as I said in a previous lecture, if you stop or don't know how to find the eigenvalues or eigenvector, always start with the characteristic equation. Okay, so if you remember, characteristic equation, we have A minus lambda I multiplied by X equal to 0. Okay, so please remember this equation. Always start with this. Okay, so just substitute. Okay, so let's say, okay, so we want to prove that your eigenvalues 1, 2, 3 is equal to 1, 2, and 3. Okay, so let's write down 2, 0, 1. So negative 1, 4, minus 1, 2, 0. Okay, so minus lambda multiplied by the identity matrix for 3 by 3 is 1, 0, 0, 0, 1, 0, and 0, 0, 1. Alright, so multiply by x1, x2, and x3. Okay, equal to 0. Alright, so this one is 3 by 3. This one also is 3 by 3. So if you want to do any operation regarding the metric, so you have to check the size. Okay, size of the metric. So if like this, means that the size of the metric are same, so you are able to proceed the subtraction operation. Okay, so from here, when you simplify, it's become, sorry, this one supposedly lambda times I. Okay, so this one should be lambda, lambda, and lambda. Alright, so lambda multiplied by identity matrix. So I skip the step here. So I just write down lambda 0, 0, 0, lambda 0, and so on. So and then I proceed with the subtraction operation. So I have 2 minus lambda 0, 1. So minus 1, 4 minus lambda, minus 1, and then minus 1, 2, and minus lambda. Okay, so after that, I find the determinant. Okay, I find the determinant of this matrix. Okay, so find determinant means that you have 2 minus lambda multiplied by 4 minus lambda minus 1, 2 minus lambda. Okay, so minus 0 plus 1 times minus 1, 4 minus lambda minus 1 and 2. Okay, so from here we simplify 2 minus lambda. Okay, so this one is minus 4 lambda plus lambda squared. Okay, so plus 2. Okay, so plus minus 2 minus should be 4 minus lambda, isn't it? Okay, so we simplify here. Okay, so we will have minus lambda, minus 8 lambda. Okay, so plus 2 lambda square plus 4 plus 4 lambda square minus lambda cube. Okay, so this one should be plus 4 minus 2, 2. Okay, minus lambda. Okay, so we simplify it. You will have cube. Okay, minus cube, and then this one 4, 6 lambda square. Okay, and then you will have minus 10 lambda, right? Sorry, should be 11. This one, another one, right? Okay, and then plus 6. Okay. Okay, so now when you simplify this cube, okay, lambda cube, so you will get lambda 1 equal to 1, lambda 2 equal to 2, and lambda 3 equal to 3. Okay, so this is how we solve problem number 1. Okay, you try to develop, this one is the cubic equation. Okay, so and this one is the eigenvalues. Okay. Right, so from here you already determine the cubic equation and also show that the eigenvalues equal to 1, 2, and 3. Okay, so now move to the question number 2. You are asked to find the correspond eigenvector. Okay, find the correspond eigenvector. So means that previously I said when you have 2 eigenvalues, you also will have 2 eigenvector. Okay, but now in our case, you have 3 eigenvalues. Okay, means that you also have 3 eigenvector. Okay, so let's do one by one. Okay, so when your lambda equal to lambda 1 equal to 1, okay, so we start with the characteristic equation. Okay, lambda I multiplied by x equal to 0. Okay, so from here we just substitute our matrix A is equal to 0, 2, 0, 1, and then minus 1, 4, and minus 1. Okay, and then minus 1, 2, 0. Okay. Okay, so let's say lambda you substitute equal to 1 multiplied by identity matrix, you will have 0, 0, 1. Okay, so multiply by x. Okay, so x here is your eigenvector. Okay, so eigenvector, you have x1, x2, and x3. Okay, so equal to 0, 0, 0. Okay, so let's say here 2 minus 1 equal to 1, 0, 1. So minus 1, 4 minus 1, 3. minus 1, 2n minus 1. Okay, so you have to multiply with this x1, x2 and x3 equal to 0. Okay, so from here we change into the augmented matrix. Okay, so that we can do the reduction of the row. Okay, so 1, 0, 1, minus 1, 3, minus 1, minus 1, 2, and minus 1 separated by a line or dotted line. Okay, so that is easily for you to do the reduction. Okay, so I can see that here one of the equation here is already have a 0 value. Okay, so I just keep it into like this. You also may reduce the row. Okay, so you may reduce the row, but for me, I just want to straight away lah. Okay, straight away. So from here, let's say here you have any value, for example 2. Okay, so you might need to do the row operation so that you can reduce the variable that you have. Okay, so if like this, okay, you already sorry. Okay, so this element is already 0, so means that you already have reducing the variable that you have. Okay, so if we write down into a linear equation, so what you have, so remember that this one we multiply by x1, x2, x3. So x1 plus x3 equal to 0. Okay, another one we have negative x1 plus 3x2 minus x3 equal to 0. So the last one we have minus x1 plus 2x2 minus x3 equal to 0. Okay, so let's say we want to let x3 equal to 0. Sorry, let x3 equal to t. Okay, so your x1 equal to minus t, isn't it? Okay, so from equation number 2. Okay, so from equation number 2, this is equation 1, this is equation 2, this one is equation 3. So it depends on you, right? Okay, so let's say I take equation number 2, I have x1 equal to minus t. So minus t times minus, okay, minus sign here. So I have t plus 3x2, okay, minus x3 equal to t. Okay, so equal to 0. So t minus t is equivalent to 0. So x2, I have 0 divided by 3, I get 0. Okay, so from here, my x1, x2, x3, okay, my eigenvector for the eigenvalues equal to 1, okay, eigenvalues equal to 1. So I have t, I can put outside. So x1 equal to negative 1, x2 equal to 0, and x3 equal to 1. Okay, so this is the answer that I get. Okay, so this is the eigenvector, okay, when lambda equal to 1. Right? Okay, so for those that doing this, okay, if you have done, okay, did you get the same answer or not? Same answer with me for lambda equal to 1?
So my answer is 1, 0, and negative 1.
1, 0, and negative 1. Okay, so correct. Okay, so also correct. It means that you let x1 equal to t. Correct or
Yes.
not?
Yes.
Okay, so it depends. Okay, as long as we factorize it, you should get the same answer. Okay, so or you can do the verification. Okay, if you get the same answer, like okay, so this one, okay, this is how we verify your answer. Okay, if you multiply, then you get the same answer, means that is correct. Okay. Okay, so this one, when your lambda 1 equal to 1, so your eigenvector is equal to minus 1, 0, 1. Okay, so when your lambda 2 equal to 2, okay, so your x1, x2, x3 will be equal to, you may do the same step, okay, but now change this lambda value. Okay, so because the eigenvalue just now we have lambda 2 equal to 2, lambda 3 equal to 3, then you may need to have 3 eigenvector. Okay, so when your lambda 2 equal to 2, so your eigenvector should be equal to, this one is I get 1 half 0. Okay, and when lambda 3 equal to 3, I get x1, x2, x3 equivalent to okay, so for lambda 2, let's say you take x1 equal to t. Okay, so you might have this one is become 210. Okay, also correct, right? Okay, any questions so far for this problem?
No, miss. Same answer.
Okay, same answer, right? Okay, I hope that determinant also you can find the determinant. Okay, so for those still don't know how to find the determinant, you may check again in the lecture number 1. Okay, we already discussed previously for 3 by 3. You may use a row or column for the elimination. Okay, to find the determinant of the matrix A, right? Okay, so I just share the answer, so you may check by yourself. Okay, so determinant of matrix A, I get 6. You get the same answer with me or no?
Yes.
Yes, Sam.
Same, right? Okay, so I can confirm that from this question. Okay, so basic understanding is that, okay, you already know how to find the determinant of the square matrix. Okay, you know how to find the eigenvalues and eigenvector, and you are understand to use the characteristic equation. Okay, when you have to determine the eigenvalues and eigenvector. Okay. Okay, now we go back to the our objective today. Okay, supposedly today we continue with the application of the matrices in engineering field. Okay. Okay. Basically, most of the engineering we cannot run from the mathematics. Okay, we cannot run from the maths, so every engineering and mathematics are related. Okay, so same goes to the matrices. Okay, so we can see that matrices a lot used in we can say that in computer engineering, software engineering, there are lots of the matrices used in this field. Okay, so if you are taking mechanical, mechatronic, if you are taking computer engineering, even in electronic also have these matrices, the application of the matrices. Okay, so for the chemical, um, um, still have a few of the application in chemical engineering use matrices, but not much. Okay, so chemical, I believe you are mostly use differentiation, derivation, right? For example, in heat transfer, mass transfer, most of it using differentiation, using the integration. Okay, so integration, differentiation, you must have this knowledge. Okay, for the chemical engineering. Okay, for the rest, for example, mechanical, mechatronic, and so on. There are lots of the application can be used in matrices. Okay, the rest, of course, same lah. Okay, right. Okay, so let look at this question. Okay, let's think about this one. Okay, so, how we solve this kind of the problem by using matrices. Okay, you may read first. Okay, I give you 1 minute to read. Okay, so the best glove here, I wish to produce the 3 type of glove. Okay, so there are 3 type. We have type A, B, and C. Okay, here the manufacturing required to process involve machine 1. Okay, so they have 3 machine to produce this glove. Okay, machine 1, machine 2, and machine 3. Okay, so type A glove require 2 minutes on machine 1, 1 minute on machine 2, 2 minute machine 3, and so on. Okay, there are 180 minutes available on machine 1. Okay, 180 minutes. Machine 2 is 300 minutes. Machine 3 is 240 minutes. Okay, so now the question asks you how many glove that the this company can produce. Okay, to ensure that they use all the available time. Okay, so how from this problem you transform it into a mathematical sentence. Okay, so from this sentence, okay, from this problem, how you use your knowledge, okay, to represent it into a mathematical problem. Okay, so here, okay, it said that you have 3 type. Okay, I write down the type here, A, B, C, and then you have machine 1, machine 2, and machine 3. Okay, so let's look at type A glove. Okay, it require 2 minutes in machine 1, 1 minute machine 2, and 2 minute machine 3. Okay, so type B require 131. Okay, and type C require 112. Okay, so this one available time 180, this one is 300, and this one is 240 minutes. Okay, So let's say how many glove that machine 1 can produce. Okay, so how many glove of type A for this machine 1 can produce around 2 minutes. Okay, so let's say we have another variable. So let's say we take X, this one Y, this one Z. Okay, so we have 2x plus, okay, and for machine 1, machine 2, we have 1 minute, okay, to produce glove type A, 3 minutes to produce glove type B, and 1 minute to produce type C. Okay, and for machine 3, we have 2 minutes to produce type A, okay, 1 minute to produce type B, and 2 minutes to produce type C. Okay, so we have okay, so if you look at into this equation, okay, it looks like a linear equation, isn't it? Okay, so from this linear equation, you can transform into metric equation. Okay, so 2, 1, 1. Okay, so 1, 3, 1. So 2, 1, 2. Okay, so in from this linear equation, you transform into metric form. Okay, so multiply with the variable that you have x, y, and z. Okay, is equal to the metric answer. You have 180, 300, and 240. Okay, so this one is already in metric form. Okay, so remember last time I said you have 3 methods to solve a linear equation. Okay, so one of it is, anyone remember?
Cramer's rules, Gauss
Cramer's
elimination,
rule.
and Gauss
Correct?
Jordan.
Yes. Okay, so
Miss,
yes.
for your machine 2, your C should be 2, right?
Okay, we check again. Glove require 1 minute, 3 minute, and 1 minute. C 1, 2, 2. Yes, correct. Sorry for the mistake here. Sorry. This one correct, right? So this one 1 to 2, isn't it? Type C, glove require 1 minute on machine 1, 2 minutes on each machine 2 and 3. So 1 to 2, 1 to 2. Okay, so from here, from this metric form, okay, you may use Cramer's rule. Okay, you may use Gaussian and Gauss-Jordan. Okay, so you can use which one that convenient to you, okay, to solve for the unknown x, y, and z here. Okay, so any question for this type of problem? Any question? No, miss. Okay, how about the rest? Are you okay? Okay or not?
Yes, miss.
Yeah,
Okay. So if okay, then we move to the another example of the engineering problem. Okay, so let's look at this problem. Okay, so this one, the mechanical student, mechatronic, I think you are familiar with this structure formula. Even civil engineering also are familiar with this. Okay, so this one is the typical static problem. Okay, so how from this static problem we can solve by using metric. Okay, so we know that in metric, okay, if you have three unknown, for example here you have f1, f2 and f3. Okay, you have to try to form a 3 by 3 matrix. Okay, so you have 3 by 3 matrix. Okay, multiply by f1, f2 and f3. Okay, you will get the this one is 3 by 1. Okay, so the answer also uh, is 3 by 1 lah. Okay, so from here try to form three equation so that you can shift into a metric form. Okay, for example here anyone know how to solve? Anyone know?
No, miss.
Maybe we can try to find the vertical resultant force first.
Okay, so correct. Thank you. Siapa who's that? May I know?
Melvin.
Okay, so thank you, Melvin. Okay, so like Melvin said, maybe we can resolve the force first. Okay, into vertical and horizontal. Okay, so let's say maybe we can write down here. Okay, maybe we try with the vertical force first. Okay, or we can say it vertically. Okay, start here. Maybe start with F1. So F1, if you resolve it vertically, you have positive F1. Right, so F1 sine 96.3. Correct? Okay, and then you have F2. Okay, when you resolve, then this one should be going down. Then you have negative F2 sine 71.1 degree. Okay, I continue down here. So this one also, when you resolve, it's become negative F3 sine 0.6 degree. Okay, and another one vertical here is plus 26 Newton equal to 0. Okay, so this one, when you resolve the force in vertically. Okay, so horizontally. Okay, so horizontally, so let's say we start with F1 first. So F1 cosine 96.3, and then F2 we have going there, F2 cosine 71.1. Okay, so another one we have F3. Okay, going to the right is a positive. Okay, so plus F3 cosine 56.6 degree, okay, equal to 0. Okay, so we have done resolve into vertically and horizontally. So remember, we need three equation, right, in order for us to substitute into this square metric. Okay, so now we just only have two equation. Okay, so anyone know how to find another equation?
We can use top.
Top. How do you know that this structure having a top?
Um, Since it's not rotating, so the torque should be 0, right?
Okay, correct. So, or we can say that we can use a moment equation, isn't it? Okay, so let's take the moment. Okay, from this pivot. Okay, so the moment equation. Okay, we have how to find moment. Anyone know how to find moment?
FD.
FD. Okay, means that the force multiplied
Force
by the
perpendicular distance.
perpendicular distance. Correct. Thank you. Okay, so perpendicular distance from the we take from this pivot. Okay, so the total length here should be 3.7 plus 2.63, 6.6 plus 1.5 is equivalent to 7.8, right? Okay, so F1 just now is vertically, so F1 sine 0.3 multiply perpendicular distance 7.8. Okay, so it should be plus. So if the moment we count into this direction is a positive, okay, and then F2, so F2 vertically, so this one supposed to be like this, minus F2 sine 71.1 degree multiplied by 1.5, correct or not? Okay, so F3, this one supposedly to be like this, 3.7 plus 1.5 is 5.2. So supposedly to be minus F3 sine 56.6 times 5.2 equal to 0. Okay. So now you already have three equation with three unknown. Okay, so three equation with three unknown. So let's say we put into a metric form. What? Okay, so from here, try. Okay, so this one sine and then another one is 56. Okay, multiply by F1, F2 and F3. Okay, remember the first one, the first equation just now you have the vertical one. So is equivalent to 9 to 6. Okay, so negative 9 to 6. Okay, second equation is horizontal, cosine okay, cosine 71 plus okay equal to 0. Okay, the third one from the moment sine sorry. Okay, and then we have 1.5. Okay, and the last one we have 5.2. negative, right? Okay, so equal to 0, 0. Okay, so from here, you may solve using that 3 method. Okay, so you might need to simplify first. Okay, so maybe you can simplify this one. Okay, if you want to use the Cramer's rule, then you need to find the determinant. Okay, so let's say this is your matrix A. Okay, so find the determinant of this matrix, and then you may find F1. Okay, by substituting the first row with this answer question answer matrix. Okay, so like that. So F1, so determinant of new A. Okay, I put the apostrophe here, divide by determinant of the original matrix, something like that. Okay, so if you want to I think this one, when you multiply, okay, so the numbers that you have here is around 0.935. Okay, so this one negative 0.946, something like that. Okay, is in a decimal number. So if you want to use the Gaussian elimination or Gauss-Jordan, it's quite difficult because we want to eliminate that one. Okay, because it involves a decimal number. So I recommended that you use the Cramer's rule. Okay, so it more easy lah. Okay. Alright, so you may try. Okay, then you can check the answer. Okay, so you may try using the Cramer's rule. Okay, you may check the answer with me here. So if not same, then we can check again lah. The step maybe you or me myself having some missing or mistake in the working step, right? Okay, so that's about the static problem. Okay, so how from this static problem we solving by using a metric. Okay, so actually there are so many engineering problem related we can solve using metric. Okay, because metric is actually represented a kind of array. Okay, so it kind of array. So inside this matrix, inside one element of the matrix, we actually can put array inside it. Okay, so because if you can see that in computer engineering, for example, okay, so we use binary number 011010. Okay, so inside 1 actually is not represent 1, so it actually has a character inside the array. Okay, so later if you further again, maybe for second semester, second year, you may experience this one. Okay, so this one is just a general knowledge. Okay, so to give you experience, to give you some fundamental knowledge about the engineering problem, how to solve by using the matrices in this case. Alright, so alright, we can see next example here. This one, maybe we can ask our friend from apa tu, electric or electronic engineering program. Who's I also forgot our friend. I think 1 or 2 student from this class from the electric and electronic, right? Okay, do you know how to solve this current in this circuit? Anyone know?
I think it's time to apply the Kirchhoff rule, is it?
Yes, okay, you may use Kirchhoff rule. Okay, so for those our friend from chemical engineering, you may refer to your friends, okay, from other program, how to solve this one. Okay, so this one maybe we can use a Kirchhoff rule. Okay, for example, let's say we take this one as a current one. Okay, so this one as a current 2. Okay, I use this number lah, Roman number. Okay, so or this one is current number 3. Okay, so how to find the current that flow into this circuit breaker. Okay, so you may write down a Kirchhoff rule. How? I also forgot this one. Okay, so 1 multiplied by the current. Okay, so remember that we have current 1, current 2, current 3. Means that you have 3 unknown. Okay, I1, I2, I3 is your unknown. So how to find these 3 unknown? Remember that you need to have at least 3 equation. Okay, so from here you have 1 times this current number 1 plus this one 25, right? So 25. Since this one is sharing, so I1 minus I2, correct or not? Plus 50 I1 minus I3. Okay, since in this first loop, here we have the voltage, so it's equivalent to 50. Sorry, is equivalent to 10 volt here. Okay, so this is our equation number 1. Okay, so equation number 2, this one 2. Okay, so 25 plus, okay, this one have 1, I2 minus I3 plus 25 I2 minus I1. Okay, no voltage is equal to 0. Okay, this is our second equation. Okay, we look at the third equation. Equal to 0. Correct or not? 55, 51. So equal to 0. So from here you have 3 equation. Okay, so 3 equation we may put into metric form. Okay, so same thing lah. Take the coefficient. Okay, take the coefficient and then put into metric form. So this one you have I1, right? So I1, I2 and I3 equal to this one you have 10, 0, 0. Okay, so please check again about the plus minus sign. Okay, so I1 you have 1 plus 25. So you have 26. So I2 is negative 25. So sorry, I3 you have minus 50. So 26 just now plus 50. 26 plus 50, 76. Okay, something like that. Okay, so this one negative 25. Okay, I2 is 25, 26 25, 26 plus 30, 56. Okay, so I3 you have minus 1. Okay, so this one 53, 55 plus 50 is 105, 106. Okay, I2 minus 1. Okay, and then I1 is minus 50. Okay, so from this metric form, you can use Gaussian elimination also can. Okay, so Gauss-Jordan also can. So if you want to use a different method, okay, you have a variety of these three method lah. Kramers, Gaussian elimination, and Gauss-Jordan. Okay. Okay. Any questions? Okay, so if no question, then we can continue, right, on the solution for the linear system. Okay, so why I highlight the linear system? Because you can see that most of the time, okay, we try to create a mathematical equation, okay, in term of a linear equation. So when you have a linear equation, okay, we try to look at into the solution of the linear system. So every linear system, you may has either no solution, one solution, or infinitely many solution. Okay, so if the system has no solution, means that you have the inconsistent system. Okay, if you have if you have one or many solution, it means that you have the consistent system. Okay, so this one, no solution, we call it as inconsistent. This one is about the system lah. Okay, so if let's say we visualize it into the xy coordinate system. Okay, let's say we have two linear equation. Okay, so these two linear equation we represent in term of graphical method. Okay, so we know that linear system or linear equation, when you sketch with graphically, you can have the straight line equation. Okay, so straight line equation, let's say you have these two equation, right? So you try to express or you try to visualize it into x and y coordinate system. So you can see these two line. Okay, so if it intercept each other, okay, so if it's intercept, okay, so means that you have two solution. Okay, let's say it intercept at one point. Okay, so at this point, so means that you only have one solution. Okay, so if it's not intercept, means like this. Okay, it parallel to each other. Okay, so it not intercept. Okay, it just parallel to another line. So this one we call it no solution or inconsistent system. Okay, so if you have only one intercept point, means that you have only one solution. Okay, let's say your these two graph are we call it overlapping. Okay, so if it's overlapping each other, so here we have infinitely many solution. Okay, so at every point on the graph here is equivalent to your solution. Okay, so this is how from the linear equation that you have. Okay, we want to see how many possibility of the solution that we have. We try to represent it graphically. Okay, so let's say you have a linear system with two variable. Okay, so this one is the example. Okay, you have two variable x and y. Okay, so when you graphically, okay, graph it in coordinate x and y, so you can see that if you have intercept, okay, for example this one, it intersect at point 32. So so this 32 is your solution. Okay, we know that x equal to 3, y equal to 2 is your solution, is your answer. Okay, so this one we call it as a consistent system with one solution. Okay, so this one you can see when you sketch the line, okay, you can see that you have inconsistent system. Okay, because the line is parallel each other, it not intersect to any graph. Okay, so from here we know that the system is inconsistent. Okay, which is having no solution. Okay, so there is no intercept point. Okay, we know that this one has no solution. Okay, so another example of the consistent system. Okay, so both of the equation have overlap at the same graph. Okay, so meaning here, okay, at every point on the graph is equivalent to the solution. Okay, so we call this one is infinite solution. Okay, there are many solution. Okay, so let's say you have three variable. Okay, so most of the time we have three variable, right? Okay, so for any linear system with three equation and three unknown, you can form like this one. Okay, you may graphical into a three space. Okay, 3D graph. Okay, so the solution, if any, will correspond point where all three plane are intersect each other. So there are only three possible. Okay, so one is no solution, one solution, and infinite many solution. Okay, same like two variable just now. Okay, so this one we call it inconsistent system, where all the linear equation, when you sketch it, it's not overlap. Okay, it just parallel each other. Okay, so this one is also no solution with two of it, okay, parallel. Okay, and another one is no solution, which is no common intersection, and this one is two coincide plane parallel to the third one. Okay, so this one also no common intersection. Okay, so two of the plane intercept, but there is no um, what we call, two of it is overlap, and another one is not coincide. Okay, so this one is the type of the inconsistent system. Okay, so where the consistent system, you can see that all these three plane, all these three equation graph has intersect at a one point. Okay, so here we have one solution. Okay, you can have many solution where the intersection is aligned. Okay, and this one at one point. Okay, this one is a line. Okay, in finite, all the plane overlap each other, all that three plane. Okay, another one is two is coincide, and another one is intersect. Okay, so this one we call it as consistent system. Okay. Right. So far, any questions?
No, Miss.
Okay. So no. If no, then we have the extra reading here. Okay. So many application of the metric in both engineering and science. You can see we use more on the eigenvalues and eigenvector. Okay, for example, if you learn control system, okay, so in control system, you need to find the damper system, vibration system, okay, so all into the control system. Okay, you can see later on for the mechanical and mechatronic student. Okay, if you are taking, I think, third year. Okay, starting from third year, you will learn about the control system. Okay, so in control system, normally you can have the vibration system, damper system. Okay, mechatronic student also learn about this one. You can see that we use the eigenvalues and eigenvector more on this topic. Okay. So another one, you can have the advanced dynamic and quantum mechanic. So a lot of the matrices that you can use into this chapter. Okay, another one is the eigenvalue sensitivity analysis in structural dynamic. Okay, so this one, if you further your study, okay, you can use a lot of the eigenvalues in this structural dynamics. Okay, but I think for the structural dynamics, not applicable for the undergrad. Okay, but if you further in a postgrad, okay, you can see lots of the usage of the eigenvalues and eigenvector in structural dynamics. Right? Any questions?
No, miss.
Okay, so if no, can I see how many of us here? "35". Okay, so wait, yeah. Since we have a few more minutes, okay, I would like to check your understanding by having a short quiz. Can we? Okay, so this quiz having no marks, but it just I just want to test your understanding. Is it you remember or not? How to find how or what we learn actually in matrices. Okay, wait, yeah. Okay, so here, I share first. Okay. Okay, so I will write down the equation here. Okay, so after you find your answer, okay, you may share at the chat. Okay, so I will count the fastest one with the correct answer. Okay. Okay, you may ready with your pencil and calculator. All right. Okay, so the question here. Okay, so the question here, can you see the slide? Can you see the slide?
Yes.
Okay, so from this matrix A and B, so you have 4 by 4 matrix, right? So from this 4 by 4 matrix, I want you to find the determinant. Okay, find the determinant.
Please show us the matrices again.
Again, show
A
the
and B
matrix.
again.
Cannot see. Okay, find the determinant for matrix A and B. Okay, so I will count the fastest one with the correct answer. Okay, you may write down your answer in chat. Anyone? Faster, faster. Okay, you have 2 0 there. Very easy to find the determinant. Okay, B, I want two answer together. Anyone give both answer, okay, for both metric together. Okay, so here we have show again. Okay, I check here. Write down the answer for A and B together. Okay, I check. Okay, so let's see who's the give the correct answer. Okay, so we have the fastest one here is the fastest with the correct answer. Okay, so we have here Al-Said Zikra Rahman Shah. Okay, so can I see your face? Al-Said Zikra, can you open the webcam? Can or not?
Yes, Miss.
Hi. So where you from?
I'm from Indonesia.
I see. So now you are in your home country or in
Yes.
Malaysia? Which part of Indonesia?
Lampung.
Lampung. All right. So you may claim the prize from me later. Okay. So good job. Means that you really know how to find the determinant. Okay, for the rest, the correct answer is let your friend do, let your friend share here. 279 for metric A and metric B is negative 255. Okay, so Neville Chin also share the correct answer here. Jefferson, maybe you can check again your working step. Okay, Anika also share the correct answer. Diora, Yoshan, okay, and the rest also, I think you know already how to find the determinant. Okay, so if got some other time later, okay, so I would like to make another type of pop quiz. Okay, so we can enhance our understanding on this topic. Okay, so basically we have done part A and part 2. Sorry, part 1 and part 2 for the matrices. Okay, so next week we can enter a new chapter. Okay, so we will start with chapter 2 on the differences. Okay, in the differential. Okay, right. So you may refer the note on the matrices here. Okay, under file. Here we have the lecture slide. Okay, I know some of you just joined this class. Okay, so you may refer to the chapter 1. Go to the file. You can see that here by the lecture 1, lecture 2, lecture 3, lecture 4. Okay, so after the class, later on, I will post the lecture 5 updated slide. Okay. Alright, there are also have the recorded video. Okay, so you may refer to here. Okay, another one more things. As I mentioned previously, our tutorial session will start by this week. Okay, so today we have a tutorial session. You may check here. Okay, so tutorial group 1 will start tomorrow, and 2 group 3 on Friday, group 4 today at 3:30. Okay, so you may join the Microsoft Team by using this team code. Okay, so please choose only one tutorial session. Okay, you will have 2 lecture class on Monday and Wednesday and 1 tutorial session per week. Okay, so please check your schedule. Choose the tutorial session that suitable to your schedule, right? Okay, so so what else? So I think that's all for me. Okay, we have done the matrices part 1 and part 2. Okay, I hope that you may use this matrices knowledge to solve some engineering problem. Okay, so hopefully next week we can start with a new chapter. Okay, so with that I take the attendance. Okay, so I see that the attendance that I download from this Microsoft Team. Okay, it shows some of you still did not come punctually joining the class. Okay, so some of you very late join the class. Okay, so another 30 minutes, another 40 minutes before the class end, then you just join. So it very I afraid that you might miss the early lecture. Okay, so please next time please join the class early. Okay, please refer back to the class policy that I mentioned in the first class. Okay, so that I will count your attendance not later than 15 minutes after the class start, right? Okay, so I think that's all for today. Thank you so much for your time. Okay, so bye bye. See you again next week.
Bye, Miss.
Thank you.
Bye.
Thank you, Miss.
Okay.